Okay, so in our earlier videos, we've seen, we have learned how to find the definite integral. So if I've got an antiderivative or an integral from a to b of f of x dx, basically what we have is we take the antiderivative of this function and we're going to plug in this boundary b into the antiderivative and subtract and plug in this boundary a into the antiderivative, and that can also be noted this way. Let's look at this example. Okay, so first we're going to take the antiderivative of this. So so the opposite of the derivative, what we do is we've got x, the power increases by 1, so we've got 4, and then we have to multiply by 1/4 here. And then here we've got this power is going to increase by 1, so we have x squared, and the 4 is there, and we're going to increase it by, we're going to divide by 2, and this 2 is because of this power. Okay, and then over here, plus 5, so it's going to be plus 5x. Okay, and now we could say, this marker's no good. Okay, so we say that we're going to do it from 1 to 2. Okay, so what that means is now I'm going to plug in the 2 in for x, and then I'm going to plug in 1 in for x. So if I plug in 2 in for x, then we get 1/4 times 2 to the 4th minus, okay, well that's just 2, right? So 2 times 2 squared plus 5 times 2. Okay, so I'm plugging in 2 in for x here. That's what we're doing when we do the antiderivative and plug in this first value. Okay, and now we're going to do, I'm going to take this value here, and we're going to subtract all of this stuff and plug in 1 in for x, so minus. So we're going to have 1/4 times 1 to the 4 minus 2 times 1 squared plus 5 times 1. Okay, so let's just stop it for a second and see what we just did. So we found the antiderivative of the function, and we're plugging in b, which is in this example is 2, and then we're subtracting the antiderivative, and we're plugging in 1, which is our a value. Okay, so after I solve all of this, 1/4 times 2 to the 4 minus 2 times 2 squared plus 5 times 2 is just 10. This simplifies to 6. And if I take all of this here, this is all going to simplify to 3 1/4. And so then if I do 6 minus 3 1/4, you end up with 11/4. Okay, and that is our answer for that one. Okay, let's do this next example. Okay, so let's rewrite this with a negative exponent. So we would write this one here as the antiderivative 1/4 of 2x plus 3 times x to the negative 2 dx. It's better to have this with a negative power than to have this in the denominator like this. It makes it easier to do our antiderivative. Okay, so now the antiderivative of this is, okay, so we've got the x is going to be increase, so that's a power of 1, so it's going to increase by 1, so 2. So, so we've got 2 over 2. This 2 here is because of that power, and we already had a 2 there, right? And then plus, okay, this power increases by 1, so we have to the negative 1 power, and then 3, and then divided by negative 1. Okay, so and that's it, and then it's from 1 to 4. Okay, so let's simplify this. So 2 over 2, that's going to be 1. So we've got x squared minus 3 over x from 1 to 4. Okay, so now we're going to plug in we're going to plug in 4 in for x. So we're going to have 4 squared minus 3 over 4. And then we're going to plug in 1 in for x. So now we're going to have 1 squared minus 3 over 1. And then we simplify this a little further. And so this is 16 minus 1/4. And then 16 minus 3/4, which is going to give me 15 and a fourth. And minus, okay, so this is 1 minus 3, which is negative 2, so plus 2, right? 1 minus 3 is negative 2, and minus negative 2 is going to give me plus 2. And if I add 2 to 15 and a quarter, that's going to give me 17 and a quarter. Okay, so here we've analyzed the definite integral. Now let's do an example where we've got to use a calculator. Okay, this one here, you're not going to be expected to do this using calculating the antiderivative, because the calculator can do this for you. So the first thing we're going to do is we get out our calculator and you hit y equals, and then you type it in here. So x, and then how do I get the e here? So you can hit second divide, and that's what gets me the e. And then I do power to the x. So there's my function, x times e to the x. Okay, so to get e, you hit second and divide. So the next thing I'm going to do is I'm going to hit second and trace to get this the integral here. So second and trace, and then I get this choice down here to do the antiderivative. Okay, now you can't really see what's happening down here, but it actually looks something like this. It goes down and up, but it's so small you can't really see it. But so the next thing I'm going to do, it says lower limit here, and we're analyzing it between 2 and 5. So when they ask you to do the lower limit, you're going to type in 2 and enter, and then type in 5 and enter. So let's just do that right now. Okay, so it says lower limit, I'm going to hit 2, and then enter. Now it says upper limit, I'm going to type in 5 and enter. And now it's telling me the area under the curve here is 586.26. And that's how to do the definite integral with the calculator. And that's all you need for your notes for tonight's assignment.